In this video, we'll be covering application of the mean value theorem. Again, this identifies find C on the interval from 0 to 2 such that the MVT is satisfied for y equals x squared. So the first thing we have to identify, again one more time, is that f of x equals to x squared is continuous on the closed interval from 0 to 2. And this is definitely true given that y equals x squared is a quadratic function, which is a polynomial, and therefore continuous on all values from 0 to 2. The next thing we've got to identify is that f of x equals x squared is also differentiable, specifically differentiable on the open interval from 0 to 2. So the way that we're going to do that is by taking the derivative of this function. You'll notice the derivative of x squared is 2x. And by taking the derivative of that function and identifying where is this function continuous, we can say that that is continuous definitely on the closed interval from 0 to 2, which implies that the original function is differentiable on that open interval. I'll say that one more time. If I take the derivative of this function and I identify the domain of this new derivative function, if this domain encompasses all values from 0 to 2, not necessarily having to include the endpoints 0 and 2, then we can say that the derivative function is continuous and therefore the original function is differentiable. So, with those two details satisfied, again, continuity on the closed, differentiable on the open, we can then apply the mean value theorem. So, the mean value theorem, again, one more time, states that if I take the derivative, f prime at a given value equals 2 f of b minus f of a divided by b minus a. Again, one more time, the mean value theorem specifically says mean, which is an average. The average slope is equal to the instantaneous slope at some point in that interval. So I'm going to go ahead and evaluate what these values are. B is 2, a is 0. I'm going to plug those values in. So I'm looking for f of 2 minus f of 0 divided by 2 minus 0, which the function is x squared. So 2 plugged into x squared is 2 squared, minus 0 squared, divided by 2 minus 0 is 2. This becomes 4 over 2, and therefore is 2. So what we're trying to say is that somewhere on the interval from 0 to 2, the derivative function has to equal to 2. So that's what I'm going to go ahead and set up. I'm going to go ahead and say that the derivative function is 2x, and the average slope is 2. Solve for x. In this case, x equals 1, which is the c value we are looking for. Again, it says find c on the interval from 0 to 2 such that the MVT is satisfied. These two details satisfies the requirements. This is my conclusion, and that allows me to find my c value of c equals 1. Is 1 in the interval from 0 to 2. Therefore, that is the location where you're going to find the derivative equaling to, again, the average slope at 2. If you look at this, again, we're going to go ahead and graph this really quick just to see the idea of what we're playing with. From here to a value of 2 somewhere out here, that is your average slope. That is f of b minus f of a divided by b minus a. And then somewhere in between, we should see a tangent line that has a parallel slope. Again, right here, which it appears that that's a value of 1, there's your value of 0, there's your value of approximately 2. So sure enough, this run here is your f prime of c, being the same value.